Hello everyone. I hope you can remember the things that we discussed in our previous lectures. So we discuss what is statistical process control, and we discuss the history of statistical process control. And in the last lecture, I introduced you the control charts, that is how you use the control charts in order to identify your process is in control or out of control. So in that case, I told you when we draw the control chart for a given process, we discuss how to draw. That is, first you have to draw the center line or the central limit of the process control chart using the mean value of your variable, and then we discuss how to draw your upper control limits and the lower control limits using the mean value and the standard deviation of your process. So in that case, what I told you is, if when you observe your process control chart, if all the observations are within the upper control limit and the lower control limit, we tend to believe that your process is in control. But even though all the points are within these two control limits, sometimes we have to observe. Sometimes when we observe the control charts, we will see some patterns in the control charts. Now, for an example, if you look at this given chart, you can see in the first part of the control chart, you can see an upward trend, and then there is a downward trend, and then there is a mixture of upward and downward trends. So if you look at this mixture, so that is showing a that is showing a random behavior. But when it comes to this upward trend and downward trend, even though the points are within the upper control and lower control limit, that gives us a hint that there is a non-random behavior, that is something wrong with your process. So even though it exhibits as in control, we have to stop your process and see what are the reasons for this upward trend and the downward trend. So in that case also, you can't believe that the process is in control. If it is in control, you need to have a random behavior, like in this case, when you look at the mixture, it's showing a random behavior in order to decide your process is in control. So you can see, if it is random behavior, you can see the first graph in this picture, right, which is showing a random behavior. In that case, if your chart is showing a random behavior, and if all the points are within the upper control limit and lower control limit, you have nothing to worry. That is, your process is perfect, it's in control. But when it comes to the second one, you can see there is a cyclic pattern, right? It's like the seasonal patterns in the time series graphs. So if you can observe these cyclic patterns, still if the points are within the upper control limit and lower control limit, that is, you have to stop your process and observe what is the reason for this cyclic pattern. So what you can easily do is, you can check whether the cyclic pattern is random or not. So we can conduct a runs test to observe whether the cyclic pattern is random or not. If it is random, no problem, your process is in control. But if it is not random, then we have to stop our process and take necessary actions in order to find the reasons for this cyclic behavior. And you can see the next two graphs, as we discussed, they are showing the decreasing patterns and increasing patterns. And if you look at the next two graphs, that is the downward shift and upward shift. If you look at the downward shift, that is, more number of points are close to the lower control limit, and in the upward shift, more number of points, they have shifted to the upper control limit. So in that case also we need to stop our process and see what are the causes for this behavior. That is, there is something wrong in the process. That's why we can see a shift in the points when we plot it, right? So that is very important when you decide whether your process is in control or out of control. Using the control chart, it's not enough just to have all the points within the upper control and lower control limit. You should have all the points distributed within the upper control and lower control limit, as well as you need to have a random behavior. All the points should be randomly distributed within that band. So that is very, very important when you are using the control charts to decide whether your process is in control and out of control, right? So I think now you are clear how to decide whether your process is in control or not by just looking at the control chart. Alright, so if you take the control chart, now you can see this is the basic pattern of the control chart. So you can see the light blue color line that I have plotted here. So that is the center line. And we discussed we have two control limits other than the center line, that is the upper control limit and the lower control limit, right? So when we are plotting the upper control limit and lower control limit, we discussed in the previous lecture, first you have to find out the standard deviation of the process. And when you plot the upper control limit, that is equal to the mean value plus 3 times of standard deviation. And when it comes to the lower control limit, mean value minus 3 times of standard deviation, right? So when you take the distance between the center line and the upper control limit, or center line and the lower control limit, you have 3 standard deviation units, right? So because of that, we call these two lines as 3 sigma lines. So since we have 3 units of standard deviation between the center line and the upper control limit, or with the center line and the lower control limit, we can define another 2 lines with the distance of 1 standard deviation units and 2 standard deviation units. So you can see when you take the center line, I have plotted another line, another 2 lines by keeping a distance of 1 standard deviation, and I have denoted that as 1 sigma. Then again I have plotted another 2 lines with the distance of 2 standard deviations, right, with the center line, and we have denoted that as 2 sigma. So when you take this 2 sigma line, so you have one above the center line and one below the center line. So when you take these 2 sigma lines, we call them as the warning limits. That is, when you plot your data, if more data points are close to this 2 sigma line, that is giving you a warning that your process is very close to get out of control, or your process is very close to give an out of control signal. So in that case, you have to be very concerned about your process. That will, since that is giving you a hint, right? So when I discussed in the previous lecture about the control charts, I mentioned about this 2 sigma limits. That's why I put this plot in order to discuss what are these 2 sigma control limits and what are these 3 sigma control limits. So in some of the control charts, they keep the distance as 6 sigma, right? So most probably they are, when we talk about the control charts, the common value is the 3 sigma control limit. So because of that, in our course also we are going to use the 3 sigma control units when we discuss about the control charts, right? So that's all about the control charts. So I hope you have a good understanding about the control charts and how to identify whether your process is in control or out of control using the control charts. So today we are going to discuss about the Magnificent Seven. So when it comes to Magnificent Seven in the field of statistical process control, we are using some of the tools in order to identify or in order to keep the quality of your process in a high level, right? Or in order to evaluate or in order to measure the quality of your process, we use these Magnificent Seven, right? That is, basically we have 7 tools here that we are using in the statistical quality control field. Actually, what we are doing is, in all of these tools, what we do is using these tools we can identify whether your process is in control or out of control, or we can identify the outliers of your process, right? So these are the 7 tools. So you have the histogram or the stem and leaf plot, and you have check sheet, you have the Pareto diagram, cause and effect diagram, defect concentration diagram, and the scatter diagram, and the control chart. Alright, so when it comes to the histogram or stem and leaf plot, so that is something you are very familiar with since the first year that you have entered to the university, and when you're studying statistics, we always discuss about the histogram. So actually why histogram is important in the quality control field is, if you just draw a histogram using the values that you are used to draw the control chart, in histogram again you can identify the distribution of your process, right? So again you can identify the outliers of the process. So the outliers are very important when it comes to quality, right? So if there is outlier, you have to find out what are the reasons for that. Okay, so that's why histogram is important. That is one of the basic tools that you can use in order to check the quality of your process. So since you are very familiar with the histogram, I'm not going to discuss how to draw the histogram. So I'm going to discuss about the check sheet, about the Pareto diagram, cause and effect diagram, defect concentration diagram, and the last one, the control charts, we already discussed in our previous lecture. And when it comes to scatter diagram, again we know when we study, when you have already done regression analysis. So when you are doing the regression, we always draw the scatter diagram in order to identify the behavior of your data set. Same thing you can do. So the scatter diagram also exhibits the outliers. If there are any, you can find out outliers using scatter diagram as well. So I'm going to discuss the rest since they are very new to you, right? So let's see what are these tools and how to use them in the field of statistical quality control. Okay, so the first thing I'm going to discuss is the check sheet, right? So what is this check sheet? So when you say check sheet, that is basically you're checking something, right? So in this thing also, what we do is, if you have a process, if you want to check the quality of your process, right, what you can do is we can observe the history and identify what are the problems you had or what are the problems that you are already having in your process, right? And then what you can do is you can count the number of occurrences of each type of problem or each type of defect at each time interval. For an example, let's say if you have a garment factory, if you are manufacturing, let's say some pants. So if you want to check out the defects, right, if you have a list of defects which are coming out from this process, for an example, if there is something wrong with the waist size, if there is something wrong with the pockets, right, likewise you can identify the defects. Then you can count how many pants are there, right, with the type 1 defect, how many pants are there with type 2 defect, likewise, right? Or else if you can find out the problems, that is there are machinery problems in this process, then how often that happen, likewise you can count the frequency. So this is the template, or this is how your check sheet looks like. So you have all the possible defects, your problems, so the type of the defect as the possible cause you can see in the second column. So there you can write down problems with the training, or problems with machines, or problems with pocket size, right, or problems with weight size. Likewise you can list down as all the possible causes which will affect to the quality of your process. So I have denoted them as 1 to n, right? And then you can observe the frequency of each cause in each time interval. So let's say you are going to count, you're going to find the frequencies in every month. So my time intervals I have denoted as January, February. So when it comes to the first time interval, that is the end of month January, I can count number of pants which are having problems with the pocket size. Then if there are 10 pants, I can write 10 here. And in month of February, if I have 20 pants with the same problem, I can denote 20 here. And then I can take the total horizontally and vertically. That is, I can take the row total and the column total both. So when you observe the row totals, you can see which cause is having the which cause occur in most of the times, right, or which cause is having the high frequency. So in that case we can identify the causes which are having high frequency. So we have to find the reasons for them. For an example, when you take the row total, let's say nth cause is having the maximum row total, let's say it's 100. So in that case, if n is equal to the problems with pocket size or wrong pocket size, that is, you have 100 pants with wrong pocket size. So you have to find out what is the reason for this one, right? And also when you take the column totals, you will get how many problems you have in the month of January, how many problems you have in the month of February. So you can check which time interval is having the high frequency of defects, so high frequency of problems. So for that also you can find out the reasons and you can eliminate those problems to improve your quality of the process, right? So this is how you develop a check sheet with your process. So you will get a more understanding when we do examples, when we do practical examples, right? So just to make sure that what is the check sheet and how we are going to construct a check sheet in order to maintain the quality of your process, right? And then the next one is the Pareto diagram. So in the Pareto diagram, we use again we find out what are the causes or what are the problems in your process. So what are the causes that are responsible for the defective items of your process. And then what we do is, you can find out the frequency of each and every course, and then you can identify each course and identify the frequencies, and then you can find out the cumulative frequencies, right? And then what you can do is you can draw a bar chart. And when you are calculating the cumulative frequencies, at the same time you can calculate the cumulative percentage as well. So using the cumulative percentage, you can draw a bar chart, so that will be more effective. And then using the bar chart, you can identify what are the major courses, right? Or what are the courses again which are having a high frequency, right? So that will also help you to eliminate those courses from your process and to maintain the quality of your process. So when it comes to the Pareto chart, we call it as 80-20 rule, right? I'll explain you that later. So these are the steps, right? Now for an example, let's say when you observe your process, right, and when you take the history of your process, you have found that there are 5 reasonable or 5 responsible causes for the defect. So I have denoted them as 1, 2, 3, 4, 5. And then at the same time I have counted, or I have recorded the frequency of each cause here. That is, when it comes to cause number 1, it has happened 40 times in the observed time period. Cause number 2, it has happened 22 times in the observed time period. Likewise, so I have all this information. So what I can do is, now here, since I'm observing the cause which is having a high frequency, I have already when I collected information, right, I have already recorded these causes in descending order, right? So you can see the cause with the high frequency, I have stated it first, then comes the cause which is having the high frequency next. Likewise, I have recorded them in descending order, right? So you also can record all the causes with their frequencies in descending order, and then I have calculated the percentages of each cause, right? That is, you have to take the total frequencies, and when you calculate the first percentage, that the first cause has occurred 40 times, 40 you have to divide by the total of the frequencies and multiply by 100. So likewise, I have calculated the percentages, and then I have calculated the cumulative frequencies or cumulative percentages. That is, when it comes to the second row, you have to add 43 and 23. When it comes to the third row, 43, 23, 16. Likewise, I have calculated the cumulative percentages as well. Okay, so what you can do is, when you calculate the cumulative percentage, when it comes to the Pareto diagram, actually we are concerned about the causes which are having high frequency, and in this case we are concerning about the major causes. So in the field of statistical process control, they define causes which are within the range 100 to 80%. Percentage is defined as the major causes, right? So you can see, when it comes to first 3 causes, if you take the cumulative frequency, that is 82%. That is, if you take total number of problems, 82% of problems are happening due to the first 3 causes. So if you draw a line here, what we do in the Pareto chart is, we draw a line with respective to 80%, and the courses which are above the line we call them as the major courses, and courses which are below the line we call them as the minor courses. So in this case, if you draw a line with 80%, you can see 82%. When it comes to course number 3, you have 82%. That is, you can take first 3 courses as major courses and the last 2 courses as minor courses. So in that case, you have to give more concern about the major courses in order to find out, or in order to eliminate those courses and improve the quality of your work. So this is also an example. That if you go back to this slide, that's why we call this as 80-20 rule. You take 80% of major responsible courses as major courses, the remaining 20% as the minor courses, right? So that is why it's very important. So when it comes to Pareto chart, you can just take down all these courses, and you can record, you can take these frequencies, and then you can calculate the percentages, and then you can calculate the cumulative frequencies, right? And then what you can do is you can find out what are the major courses and what are the minor courses using just using this table. Or else when you draw the Pareto chart, again you can go to a bar chart as well. So I will show you the bar chart. Which you can draw using the Pareto diagram. Right, until that I will explain you the next. Right, so this is the, you can see the Pareto diagram that I have drawn. So that is actually an image that I have downloaded. In this case, if you look at the x-axis, you can see they have defined all the problems of the process. Right, that is the documents, you have the product quality, you have the packaging problems, delivery problems, and the other problems, and they have plotted with the frequencies here. Right, so you can see when it comes to this process, so they have drawn this Pareto diagram for the second quarter in 2005. In this case, we can see most of the times they are having the problems with the documents, and again with the product quality. So these two are the major problems in their process, right? But here you can see, if you look at the y-axis, they have used just the frequency here, right? In this case, actually when we look at this Pareto diagram, these bars, even though we can identify what are the major courses or the courses which are having high frequency, this is useful only if all the courses are having if all the courses are equally important, right? So in this case, if you look at the courses that they have defined here, if packaging, delivery, product quality, document, and other type of courses, if they all are equally important, it is okay to draw your Pareto diagram like this. In that case, you can identify what are the major causes. But if they are not equally important, this will mislead us, right? For an example, if documentation is more important than delivery, or if delivery is more important than documentation, right, we can't say that documentation is a major cause, right, if delivery is more important. So in that case, when you draw the Pareto diagram, we have to do some modification. So what we can do is we can assign weights for each and every cause, and when we are calculating the frequencies, right, what you can do is we can use this weights, and you can calculate the weighted averages for each and every course. So when we are doing practicals, we can we will discuss how to draw your Pareto diagrams like that, right? So you have to remember, if you just take the frequencies to your y-axis and draw your Pareto diagram like this, all the possible causes should be equally important. If not, you have to use a weighted average, right? And then the next one, that is the cause and effect diagram. So in the cause and effect diagram, what we do is, first we have to define the problem or the effect that we want to be analyzed. For an example, let's say you are manufacturing a light bulb and there is a problem with the filament. So your problem is first you have to identify the problem, or let's say there is a problem with the lifetime of your light bulb, right? So the problem is the lifetime of your light bulb. So first you have to identify what is the problem that you are going to analyze, and then what you have to do is we have to form a team to analyze this problem, right? And then what we do is when it comes to right, if you look at this diagram, so you can see first you draw a center line with the effect or with the problem. So that is what in this diagram you can see that as the defect, right? That is the problem or the question that we are going to analyze. So in the example that I discussed, it is the lifetime of the bulb. So if you are going to analyze the lifetime of the bulb, then you have to find the possible causes for this problem. So let's say there are problems with the materials, or there are problems with the employees. Those major problems you have to identify, right? To that you have to form a team, right? And then what you have to do is, you can see first you have to draw the effect box, that is the center line, and then you have to specify the major potential categories and join them as boxes connected to the center line, and identify possible causes and classify them into the categories which we discussed in the earlier step. If there is no category, you have to find out a new category and rank order the causes to identify those that seem most likely to impact the problem, and then we have to take correlation action. It's like this. So in this case, we can see the center line, that is the problem is the lifetime of the bulb, that is the defect. So for the lifetime, measurements, when you are taking the measurements of the production, it can be a problem, and another cause can be materials and personnel, machines, method, or sometimes the environment. So if you find a problem, let's say when you observe your process, you have identified one of the problem is the problems with the operators. So it's coming under the personnel category, so you can put it under the personnel category. So if you found another problem with the speed, so it's coming on machine speed, it's coming under the machine category. Likewise, you have to place the causes under the relevant category. But if you didn't find a category to place your cause, you can construct, or you can identify that course as a new category and put it there, right? And then for each category, then you will have several courses. Now if you look at this diagram, you can see under the personal category you have 3 courses, that is the problems with the shifts, training and operators. In that case, you can take the frequencies of each of these courses, and then there you can take them as in descending order and identify what are the major problems, right? So in each category we will be able to find out what are the major problems, and then we can find out the correlation between the defective correlation between the problem and the scores, and then we can, if there is a high correlation, we can take necessary action. So when you are doing this cause and effect diagrams in the field of process control, there is a specialized team for that, because they have been brainstormed for this special process, right? So it should be done very precisely in order to identify all of these categories as well as the courses, right? From this also you can improve the quality of your process. So the last one that we are going to discuss, that is the defect concentration diagram. So that is actually, it's a picture of the unit showing all the relevant views. For an example, if you are manufacturing a refrigerator in your company, and if there is a problem with the door of the refrigerator, or if there is a problem in the freezer, what you can do is you can take pictures in all the angles of the freezer in order to identify what is the problem. Right? So there we take various types of defects on the picture, and then we identify the relation between the location of the unit and the potential cause of the defect, right? So with that also we can identify, when you take several pictures of each unit, we can identify where is the problem and what is the relationship of each unit is having towards the problem or towards the defective item, right? So likewise, the defect concentration diagram is also something important that we can use in statistical process control field, but it's more into the graphical side. But the other things that we discuss, you have calculations as well, right? So all these magnificent 7 tools you can use in your process in order to monitor your process, to find out the causes, right? Find out the causes which are responsible for defects, or find out the causes which are responsible to get an out of control signal, and then we can eliminate these causes, right? We can eliminate these assignable causes and improve the quality of your process. So I hope you are now having a good understanding about the magnificent 7 tools. So I'm going to stop for today, and we will discuss more about statistical process control in the next lecture series. Thank you.